Hello, ladies and gentlemen. This is Surfer Do Tutoring. Thank you so much. So today we're going to do multiplying and solving multiplication and division equations. And so just to review a few things. So we've learned about inverse operation, meaning the opposite, performing the opposite operation to each side. We've learned about isolating the variable, and we've learned about balance the equation, okay? And we've learned about balance the equation. So we're going to just continue to apply these. We learned these for addition and subtraction. So we're just going to continue to apply these principles in these three skills really to multiplication and division. So I'm going to do two multiplication problems and I'll do two division problems, and then I'll go ahead and upload and you guys can get a look at it. So for the first problem, we see that we have a variable with a coefficient, right? And that automatically means it's a multiplication problem. And so the inverse operation is to use division, and I'm going to use just a different color in order to show that division. So here's going to be a division problem. So we're going to divide both sides by 3, right? So that means that I have balanced, and when I cross through this, I've isolated my variable, and then 15 divided by 3 equals 5. And then I'm going to check my work by just taking this solution, x equals 5, and plugging it back into the original equation. So 3 times 5 equals 15, and then we're just going to show, because we can do math right here, and we're going to simplify this side of the equation. So 15 equals 15, and that's a true statement. So we've just followed our normal, regular progression, inverse, isolate, and balance, right? So let's go ahead and do this with 7 times 7x equals 721. So the first thing I'm going to do is, this is a multiplication problem. I know it is because I have a number and I have a coefficient and a variable. So I'm going to divide both sides by 7. So now I know that I'm balanced, right? I know I'm balanced. Why am I dividing by 7? So that I can isolate the variable. So x is equal to, so 7 goes into 7 one time, 7 goes into 2 0 times, and 7 goes into 21 3 times. Now, if you need to do the math for that, that's completely fine. Just go over and do 721 divided by 7. That's all you got to do. So 1, which is 7, subtract 0, bring down the 2. That's a 0 because 7 doesn't go into 2. So bring down the 1, so 21. So then you've proven and done your math to show that work. So now I'm going to plug this back in. So 7 times 103 equals 721. So 3 times 7 is 21, carry the 2. 7 times 0 is 0 plus 2. And 7 times 1 is 7. So 721 equals 721. And that's true. So how do we know, and this is a question that's been coming up in a number of classes. How do I know when my inverse operation is division, and how do I know when it's multiplication? Well, a coefficient next to a variable is multiplication. I guess maybe I should go ahead and do while I've got this problem up, let's just go ahead and do sometimes we have fraction coefficients. So let me just go ahead and do something like 2/3 x equals 10, right? 2/3 x equals 10. So we have a special rule when we are dividing. So this is multiplication. So I've got my coefficient, which is a fraction, but it's still a coefficient and a variable. So it is a multiplication problem. So typically what we do is we don't divide fractions. We multiply by the reciprocal. So if I multiply by the reciprocal here, I'm going to end up with 3 over 2 on this side, and then balance, and then I end up with, I should have done that, with 3 over 2 here, okay? And so then these two cross each other out, or they cancel each other out, equal 1. So I've got the identity property here, so x is equal to 30 divided by 2, and 30 divided by 2 is going to just equal 15. So then we do our check and plug it back in. So 2 2/3 times 15 over 1 is equal to 10. So 2 times 15 is 30. 3 times 1 is 3. So we're 30 over 3 equals 10. And that's a true statement, and we will accept that. I don't feel like I need to do a decimal. Decimals is just regular, it's just a regular problem. But let's do some division problems now. Let's just do something like f divided by 8 equals let's say 20, okay? Let's say 20 to begin with. So now we've changed from a multiplication problem to a division problem. Well, how do we know this is a division problem? And as one of the students says, it's got a fraction bar. Well, but that coefficient we just had with a fractional coefficient, that had a fraction bar also. But this has a variable in the numerator. So that means it's f divided by something is going to give me 20. So I've got some number. When I divide that number by 8, I end up with 20. So it's a division problem. So we're going to undo division with multiplication. And so we're going to show that multiplication in a different color. So we're multiplying by 8 here, and we're multiplying by 8 here. So 8 divided by 8 crosses each other out. I have balance because I've done this. Now I've isolated my variable, so I have f is equal to 20 times 8. Well, 20 times 8 is 160. So now I'm going to take this and plug it back in. So I know 160 divided by 8 equals 20. So 8 goes into 16, 2. 8 goes in there, 0. So 20 equals 20. And that's a true statement. Okay? So then what about, let me do one more. What if I have something like m divided by 3.2 equals 6, right? Or 6.4. We'll just say 6.4. So I've got some number. I divide that number by 3.2, and I end up with 6.4. Well, this is a division problem. M divided by 3.2. So I know that I have to do multiplication to solve this problem. So I'm going to multiply by 3.2 here, and I'm going to multiply by 3.2 here. Well, if I multiply by 3.2 in both of those places, here I cancel out, right? So now I've got, and I'm balanced. So I've balanced, I've isolated my variable, and now I just need to do, and I'm going to do this, can we see? Now I'm going to go ahead and do it here. 6.4 times 3.2. So this is 8, this is 12, placeholder. This is 12, carry the 1, 19. So I've got 8, 4, 0, carry the 1. I've got 20.48. So 20.48 is M. So how do I get that? Well, I multiply both sides by 3.2. This cancels out. So the identity property leaves me with just M. So then 6.4 times 3.2 gives me that. So then I'm going to plug it back in and see if this is really true. And this is where some of you are getting like, well, Mr. Raber, I don't really know why I need to do that. Well, because sometimes we make a mistake. So Mr. Raber is going to check and see if I made a mistake here. Divided by 3.2 equals 6.4. So now I've got 20.48 divided by 3.2. Well, I need to move this decimal one place to the right. So I need to move this one place to the right, put it up to the top. So 32 into here. Well, let's just say it goes 6 times because that's what our answer was supposed to be. So 6 times 2, 2, carry the 1. 6 times 3, that's 19. Okay, so then I end up with what? What do I end up with here? Well, we bring down the 8, right? Borrow here, we get 19. So this is, sorry. I don't need to borrow. So it's going to be a 2 and a 1. 128. So supposedly it's supposed to go in 4 times, so let's do times 4. 8, 28, good. So that comes out exactly correct. So that's why we check our work, just to make sure that sometimes we can't do the work in our head, and to double check what we've done, we just plug it back in and work it backwards. So ladies and gentlemen, once again, it doesn't matter if you have a multiplication or multiplication problem, a division problem, an addition problem, or a subtraction problem. Inverse operation, balance on both sides, isolate the variable. That's how we do it. So you have examples with these videos. You now have examples of multiple problems, and you can use these examples plus the examples that you've taken in notes in class to help you understand what's going on. So, dude out. Thank you. And catch.